In this example, we are going to continue with defining algebraically a vector. So the vector looks like this. So vector u has almost a coordinate to it, AB. It's going to be coming from the origin. The A represents how far horizontally, the B represents how far vertically. So it's pretty much treated like a coordinate. To find the magnitude, you're really talking about potentially Pythagorean theorem if you know these two values. And then if you're finding the angle, you are kind of looking at doing tangent because you would know the opposite and the adjacent. But in this situation, you're looking for A and B given the magnitude and given an angle. Now, there may be formulas and everything like that, but I don't even think about it because I just draw a picture, and most likely, if you're watching this, you're in a trig class and nothing new really needs to be done with this at all. Once you draw your picture, I think you'll see. So if we draw our picture, we have an angle of 128.5. So we are somewhere in the second quadrant. And so, and we are, I don't know, somewhere middle-ish. So that angle right there is 128.5. All right, so what that kind of gives me is the reference angle. The reference angle is me taking 180 minus 128.5 and getting 51.5 degrees. All right, so then I can drop this down, and I know the length of the hypotenuse because the magnitude is the hypotenuse. So that value is 198. So what I'm looking for is, I'm looking for this value, and I'm looking for this value. Those are your A's and B's. So I'm just going to do basic trig. So to find A, I'm going to be doing cosine. So cosine of 51.5 degrees is going to equal A over 198. All right, so if I do this math, I'm going to multiply the 198 over, and A is going to equal whatever this value is. Now, I'm going to get 123.3 out of that. So, realize that when we do our final answer, we are making a vector, and so there's a direction to this. So that A is going to the left, so we're going to have a negative 123.3. And then if we're going to do the B value is going to be sine, so we'd be looking to do sine of 51.5 equaling B over 198, multiply 198, and if we do this math in the calculator, we get about 155.0. Now that's going up, so that should remain positive. So that is our vector written algebraically. All right, so good news, nothing was new. I could have been using potentially other formulas, but I'm just going to let this draw my picture. I'm going to draw my angle, figure out what my reference angle is, make a right triangle out of this thing. The magnitude is your hypotenuse, and then just do stuff you're already familiar with. All right, so let's do one more example. So, and we're going to write the exact form. Now, when you see the word exact form, that's telling me most likely it's coming from values of a 30, 60, 90 or a 45, 45, 90. So, let's draw our picture. We have a magnitude of 10, and we have our angle, our direction of being 120 degrees. So 120 degrees ends up being here. So that is 120. Reference angle wise, if you drop down this, that makes this 60 degrees, which this just became a 30, 60, 90. So on a 30, 60, 90, if you remember, there's these references, there's relationships between your 30, 60, 90, that, and everything kind of builds from the side across from the 30, where this is x, this is 2x, and this is x root 3. Well, you have the hypotenuse. So if we have the hypotenuse being 10, if we drop it back to the one across from the 30, we're going to be cutting it in half. So if that's 10, that puts this measurement at 5. And if this is 5, then this is going to be 5 root 3. And then I'm going to put the negative on it just to keep it appropriate. So our a value is negative 5, and our b value is 5 root 3. And that is our vector. So when you see the word exact, it definitely means that you're going to have some sort of a 30, 60, 90 or a 45, 45, 90 most likely. And that was 2 more examples of algebraically defined vectors.